For each positive integer n, define s into the smallest positive integer divisible by each of the positive integers 1 to n. For example, s5 is equal to 60. How many positive integers n, where n is between 1 and 100 inclusive, have the property Sn is equal to Sn plus 4? In order to illustrate the problem, I've created this graph where all the red squares are numbers that can be represented with this, with n of k, where n is prime and k is a positive integer. And these crosses is where Sn is equal to Sn plus 4. So this square, which would be 32, is equal, so S32 would be equal to S36. And, you know, that's obviously a grid-based system where you have 0, 1, 2, and all that. Where these are the 1s and these are the 10s. So, why specifically have I isolated these types of numbers? Well, the reason for this is because no number that is less than these numbers can be multiplied together in such a way to create this specific number if you were ignoring common factors between the numbers. So for example, 8 is 2 to the power of 3, which you could say you could just multiply 4 by 2 to get, but since these two have one common factor of 2, in reality you would only end up with 4, which is a bit confusing to understand, but I don't think it I think you can I think it's not that difficult to understand, but I think it's fine, really. So we have this, and basically all you need to understand is that if Sn plus 4, if you have n, say this is n, and therefore this would be plus n plus 4, if any of these numbers, the 4 boxes after n, is red, that means that Sn has changed. So, in order to find out where Sn is equal to Sn plus 4, I created this figure, and for every place where there's a gap of white squares that is 4 or more, there's going to be some number of some values of n, where Sn is equal to n plus 4. And it depends on how large the gap is. So here it's 4, therefore there's only one number, and it's here. However, here there's 2, and I just signify this with the number here, because there's 5. You can effectively think about it like, what is the gap minus 3? And if it's 0 or negative, then it's, well, there's nothing there. So here there's a gap of 5, so there's 2 numbers, 2 more gaps of 5, there's 4 more values of n, and then here it's a gap of 7, so 7 minus 3, 4, done. And this is 105 to 109, and those are not relevant to this. So ultimately we uncover that there is 1 plus 2 plus 2 plus 2 plus 4 values of n, which is 11 values of n, where Sn is equal to Sn plus 4. So we have 11 as our final answer. Question 4. In the multiplication problem below, A, B, C, D are different digits. What is A plus B? So here we have the original equation, and the most simple and most intuitive way to solve this is to recognize that in order to create a number of this pattern, of this number as a factor, you just need to multiply it by 101, and then you'd get this pattern. There's any two-digit number in this pattern, multiplied by 101 is equal to this number in this pattern. And that's the most intuitive way to solve it. But if you want to solve it algebraically, you could represent this equation like this, where you have 101a plus 10b multiplied by 10c plus d, representing that this a is in the hundredth digits, this b is in the tens digits, this a is in the ones digits, and then you have that equal to the same principle, but with this, with c and d, and then you have this equal to this number represented in that way as well. So we continue the equation and we continue the equation and we try to solve it, and we get to this point. This is where we see that 110a plus 100b times c plus yada 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 is equal to 110c plus 101d. Now you can do this either way with c or d, where you can have 101a plus 10b be equal to 101, and or you could have 1010b plus 100b equal to 1010. Either way works. We use these numbers. I use these two numbers for this, but you can use either. And you get this equation where, since a and b can only be positive integers, or 0, okay, 0 and positive integers, therefore a must be 1, b must be 0, and a plus b is equal to 1. So the answer for this question, would be A.